Good morning, guys. Hopefully you've had a good weekend. I guess it was a long weekend for you guys because you had the Friday off. If you want to throw some green checks in, so you let me know you're with me and everything's working okay, and we'll get started. I see a good morning in chat, so I'm thinking things are good. Some green checks pouring in. Good. There's been a bit of a change of plans today. Unfortunately, Mrs. Ward is not feeling very well, so she's at home. And we're probably going to end up doing math for most of the morning. I know we did start a little bit late, so I'm thinking we'll probably do maybe like a lesson, and then we'll take a bit of a break in the middle, maybe like 20-30 minutes, probably around 20. And then you'll have a little bit more stuff. And it kind of works out well where we're at in terms of this unit, because there's kind of a bunch of ideas that are all kind of thrown together and give you some time to kind of digest it. You'll probably have a day later this week where you don't have math and you'll just have English instead. So it's kind of what's going to happen, likely. Looks like everybody's got some green checks in there, which is good. Everybody have a good weekend? Anyone do anything exciting? Go anywhere? I know you guys are all very busy. I had swimming lessons with my son yesterday. That was the highlight of my weekend. Anyone top that? A few people typing. If you would like me to go over anything from the learning guide, maybe let's just hold off on that for a second. I just wanted to mention a few things. We had some stuff from the lesson last day, and the way the course is kind of set up is different from the textbook, and it's different from how I teach it, so it's all kind of like jumbled together. And I kind of went through some stuff last day, the exponent, rational exponent stuff that I probably should have held off on for a little bit. So what I'm going to do is I'm going to go through the next section, which is had a little bit of stuff that I introduced last day, and I'm just going to spend some more time on it. And then there's some additional questions that I'd like us to go through, because this stuff gets really, not necessarily tricky, but it's just kind of a lot in one question. So just want to take a step back before we kind of go forward. And notice, Alex, you put some questions into chat there. That's good. Chloe made cookies. What type of cookies did you make, Chloe? Babysitting and some ballet. Well, it doesn't sound like a super exciting weekend, but I guess that's what it is. Sugar cookies, those are good. Did you decorate them with lots of icing and fun sprinkles and things? Those are my favorite type. My son likes to decorate the cookies that we make in our house. Yes, good. That's the best type of cookie. So I'm going to just take a quick look at the questions you guys put in here, and then I'm going to spend a little bit of time going over some of them. It's kind of weird how everything kind of gets mixed in together, and all the rules kind of show up in the questions, and the order I went through it last day wasn't the best, so it's a bit my fault. So I have a few questions for 3C and D, and then 6, 7A. So let's look at page 4 first, and let's have a look at what that was. Page 4, C and D. Okay. Three C and D of the learning guide. All right. So this is stuff that I probably haven't gone through yet. So we'll have a look at this. So the idea here is we are simplifying. So we're trying to get rid of any negative exponents, first of all. This question isn't at that point yet. It's just all positive exponents. But we know when we divide with our exponents, we always subtract. So let's take a look at C here. The first thing I'm going to do is, I kind of mentioned this before, I kind of like just cross these numbers off and cancel them as we go. So I see that I have a common factor between my two coefficients out front here, I know 3 goes into 3 once, and I know 3 goes into 12 4 times. So I kind of cross them off, away I go. And then I see I have x's and y's and z's that I need to deal with as well. So you can do it this way, or you can do it, I'll do it twice again maybe. I see I have x to the 8 on the top, and then I have 6 on the bottom. So I know 8 minus 6 is 2. So I'm going to cross that off and change that to a 2. And then 7 on the top, 4 on the bottom. 7 minus 4 gives me 3. So I'm going to cross off all of them on the bottom. You'll be left with 3 here. And then I have 2 on the top and 1 on the bottom. So I get rid of that and be left with a 1. So I can rewrite this as 4x squared y cubed, and then z to the power of 1, or just z. Yeah, Tay, that's exactly what I've just done. Can you do 12 over 3? Which is what I've done. 12 over 3 is just 4. That's just a different way of doing it. So that's kind of the first way. The second way is you can just rewrite this whole thing. So I can go the 4 divided by or 12 divided by the 3 is the 4. So I get 4. Then I can go x to the, 8 minus 6. Y to the 7 minus 4. And z to the 2 minus 1. And then I get 4x squared y cubed z to the power of 1. So you could write it out that way, or you could just do it the way I did it. So canceling them out right in the question or subtracting them, you end up at the same spot. Just kind of personal preference, whatever kind of makes the most sense to you. So let's look at D. I'm going to deal with them separately. So if you think about what we did with C, it's kind of like 2 questions, and then we're going to multiply them at the end. So again, anything common here? Well, I see I have a 15 and a 9, and I know 3 goes into both those things. So 3 goes into 15 5 times, and 3 goes into 9 3 times. My x to the 9 on the bottom, I'm going to subtract 5. So get rid of my 5. That leaves me with 4. 8 on the top, 4 on the bottom. Get rid of all 4 of those, and I'm left with 4. I'm going to just continue on here. 3 and the 5 and the second one, we can't do anything with. There's nothing common there. So I'm just going to leave that. The 7 and the 3 is going to give me a 4, and the 6 minus the 2 is going to give me a 4. So I'm just going to rewrite this now. I get 5x to the 4, y to the 4. All that is over 3. And over here I have 3 over 5, x to the 4, y to the 4. All right, so these things are being multiplied by each other. When I multiply, I add my exponents. So if I have an x in one bracket and an x in the other, when I multiply them together, I'm just going to add. You'll notice that the 3 and the 5 kind of strategically worked out in this case. And you'll see what I'm talking about here. I have a 5 on the top, so I'm going to go the 5 times the 3 is going to give me 15. And on the bottom, I'm going to go 5 times the 3 is going to give me 15. So what actually happens here is the 5 and the 3, if you like to think in terms of canceling, you're going to cancel the 5 on the top with the 5 on the bottom here. The 3 gets canceled with the 3. Or if you just divide the 15 on the top by the 15 on the bottom, you end up with 1. My x's, I'm going to add them. So I'm going to have 4 here, another 4 here. So I have x to the 8. And then y, I have 4 and 4, 8. So that's all I am left with. And again, these things always all just kind of cancel out and work out to these kind of simple answers from these really complex looking questions. So that hopefully sorts that out a little bit. There was one other question in chat, page 6, question 7a. And this one has a negative exponent. I might as well just do it. I'll give you guys some time to work on the review and then, or the learning guide here, and then about midway through this long block we're going to have today. And then if you have any further questions, I can answer them at the end. So I have this 4 over 2, 4 to the power of negative 2, sorry. In order to make my exponent positive, I have to find the reciprocal. So what I'm going to do is I'm just going to end up putting it on the bottom. So because I have nothing on the top, I just have a 1 up there. I'm going to have 4 squared on the bottom times 5. And then 4 times 4 is 16 times 5. I don't know what that is. 16 times 5 gives me 80. So I just end up with 1 over 80 there. So the negative exponent 2 just means we put it to the bottom. Now I know maybe I didn't do a really good job of explaining the negative exponents last day. So what I'm going to do is I'm just going to talk a little bit about fractional exponents a little bit further today, because they popped up in the lesson, but I didn't really want to talk about them today, but just kind of how it all worked out. So if we can go on to lesson 3, then I'll give you guys some time to work. The good news is lesson 4 is just all the rules together. So it's just kind of a review of all of this stuff. So I can try to give you little pieces of everything, and then you'll have some time to deal with it all. So this is lesson 3, fractional exponents and radicals. The idea of this is converting back and forth between an exponent, which is a fraction, and a radical, or a radical and then an exponent as a fraction. So let's look at a couple things. 0.87 to the power of 1. Anything to the power of 1 just ends up being itself. So this is going to be 0.87. And then I have 0.87 to the power of 0. Well, anything to the power of 0 equals just 1. So if I asked you to come up with an estimate for 0.87 to the power of 1/2, what would you think that would look like? What would you end up with? Oh yeah, and that's a good point, Abby. We missed out on the last 2 questions was it just the last one? Yes, it was just the last one of the unit, lesson 2. Do I want to do that now, or do I want to do that later? Let's do it now. I apologize. We're going to take another step back. Kind of all over the place here today. Sorry for that. Let's do this last question from last day that I didn't have time to do last class. So I know I rushed through this one here, the one before it, and that I apologize for that last day, but let's spend a little bit of time doing this one because it's a similar style of question, except it's a little bit trickier. So we dealt with negative exponents. We know when we have a negative exponent, if we want to make it a positive exponent, we need to take the reciprocal, or flip, whatever that exponent's acting on. So in this case, I have the exponent of negative 3. I need to flip everything inside those brackets, and that'll make my exponent positive. So let's look at that. So whatever's here, we're just going to flip it. So I'm going to write a fraction. I had a 12 on the bottom. I'm going to put it on the top. And I had a 4 on the top. I'm going to put it on the bottom. And everything's just been flipped. Now my exponent becomes positive. All right. We also have some negative exponents within the bracket that we need to deal with as well. And the thing about these types of questions is there's like 100 ways to do them. And no way is any more correct than the other. So you can choose to deal with your negative exponents whenever you want. You can do them right at the beginning. You can do them at the end. It doesn't matter. I kind of like getting rid of my negatives at the beginning because once I've gotten rid of all my negatives, I generally don't have to worry about them anymore. So I have negatives inside of my brackets. Let's deal with those right now. So the 12 and the 4 are just going to hang out here as we could simplify them, but I'm just trying to think of one step at a time. I have this x to the power of negative 2. If I want to find the reciprocal of x to the power of negative 2, and it's on the top, I can put it on the bottom, and now my exponent becomes positive. So now x to the 2 is on the bottom. I'm going to do two steps at once here. I have this x to the negative 3 on the bottom. Because it's a negative exponent, I can bring it to the top, and now it becomes positive. So anytime I have these negative exponents, if I want them to become positive, I can just flip them to the top, or flip them to the bottom. I'm going to simplify everything inside of my brackets. If I'm going according to order of operations, we can do bed mass. Brackets comes first. So everything in the brackets first. 12 divided by 4 is going to give me 3. I can do it as cancellation if I want. 4 goes into 3 once. I have x squared on the bottom and x cubed here. So 3 minus 2 gives me 1. So I end up with 3x, and this is all to the power of 3. So I've done what's inside of my brackets. Now I can deal with my exponents that are outside of my brackets. So if I have an exponent here, both things inside the bracket here need to get this exponent. And of course, I didn't write it in, but these both have an exponent of 1. So I'm going to go 3 times 1, 3 times 1. So I'm going to get 3 to the power of 3 and x to the power of 3. And 3 to the power of 3 is 27 times x to the power of 3. All right. So when you guys do these questions, there is lots and lots of ways to do them. You could have started at the very beginning when I first had that 3 on the outside. I could have multiplied it through by everything. It just kind of depends on how you want to approach it. Always in math, when you're doing things that have more than one method, you want to stay really consistent with what you're doing because it just makes everything easier if you do the same steps in the same order all the time. That way you kind of know how to get through these things. So hopefully that kind of doesn't confuse you. I'm going to jump back to lesson 3. And then we'll go through this stuff. I'll try to sort out this fractional exponent stuff that I introduced last day, which was foolish of me, but I did. Hopefully we can wrap our heads around it today. So we looked at 0.87 to the power of 1 was 0.87, and 0.87 to the power of 0 was just 1, because anything to the power of 0 is 1, except for that 0 to the power of 0 thing. So we had to figure out what 0.87 to the power of 1/2 was. We could probably, estimate it somewhere between 0.87 and 1. So let's fill out this little table and see where this leads us. Use a calculator to complete the second column. So I have x to the power of 1/2. If I have 1 to the power of 1/2, I have just 1. If I have 4 to the power of 1/2, that's going to give me 2. 9 to the power of 1/2. This is where we're going to break out our calculators. We got a new little camera here. Let's see if I can do this. I want you guys to make sure you know how to use your calculator. So on my calculator, if I'm going 9 to the power of 1/2, I'm going to put in a 9. And then I have this y to the x button that I'm going to hit. It gives me a little hat. And then I can do it a couple different ways. I can do a bracket, 1 divided by 2, close the bracket, and hit equals, and I get 3. It's just going to depend on what your calculator looks like and how your calculator works. Another way to do this is this. I can put in 9. I can hit my y to the x button. I can go 1, and then I have a fraction button here, a over b. That means 1 over 2, and then I can hit enter. That gives me 3. So it's another way to do it. If you have an a over b button, you can do it that way. I can't think of any sort of other method that would happen on your calculator. Some calculators will accept a fraction. Sometimes you'll have to put in brackets around it. Let's see if my calculator likes this. If I go 9 y to the x 1 divided by 2. See, that doesn't work. And the reason that doesn't work is my calculator is going, okay, that's 9 to the power of 1, and then I'm going to divide all of that by 2. So the calculator doesn't understand order of operations that you're trying to feed it. So when you're putting these things in, instead of 9 to the power of 1, which is just 9, divided by 2, which is 4.5, you have to make sure to put that fraction in brackets, or as an alternative, if you have a fraction button on your calculator, you can use that as well. I have a Staples calculator here. It might be similar to what you have. Let's see if I can figure this one out. 9 to the power of, yeah, this one's going to be 1 over 2 in brackets. Gives me 3. What if I go 9 to the power of 1 divided by 2? 4.5. Again, it's going 9 to the power of 1, and then it's dividing the whole answer by 2. Do I have a fraction button on this one? I've never used this calculator before. I'm just kind of stole it from Mr. Beetlestone. I have a B over C button here. Let's try that. 9 to the power of 1 fraction 2. Hit equals 4.5. Yeah, that didn't work either. So it's giving me 4.5. That's not what I want. If I go 9 bracket 1 over 2, close the bracket. Oh, I forgot the exponent there. Sorry, 9, 1 over 2, I end up with 3. All right, so that's kind of, how does your calculator work? Back to this old song and dance again. Good question in chat. Why isn't it actually half of 9? What we're doing here is, if we wanted half of 9, we would just go 9 divided by 2, but the exponent works out a little bit differently. We're going to spend some time looking at how to convert back and forth, and hopefully that'll kind of clear up your question. So let's look at a few more examples here. 9 to the power of 1/2 was 3. 16 to the power of 1/2 is going to give me 4, and 25 to the power of 1/2 is going to be 5. So perhaps you see a bit of a pattern emerging here. It's good. Anytime we have something to the power of 1/2, we are asking ourselves what number multiplied by itself gives us that number. So in this case, it's the exact same thing as the square root. So if you can imagine that a power of 1/2 is the same as the square root, and those are all perfect squares, a little light bulb went off for Abby, which is good. What if we did perfect cubes? And instead of doing the power of 1/2, we did the power of 1/3, which is the next table. So let's fill this guy out. And again, I encourage you guys to use your calculators to try to figure out how these things work, because half the battle is your calculator. So I have 1 to the power of 1 over 3. I'll do that one for you. It's going to be 1. How about 8 to the power of 1 over 3? I wrote 2, but I meant 3. 27 to the power of 1 over 3. 64 to the power of 1 over 3, and 125 to the power of 1 over 3. You probably could figure these out just by looking at them, but it's important that you know how to use your calculator. So I need you to plug these into your calculator right now to make sure you kind of understand how it works. So I see some solutions pouring in here. 8 to the power of 1 over 3. Maybe I'll try a few of them while you guys are doing this. 8 y to the x. I'm going to use brackets. 1 divided by 3. Gives me 2. Do the next one. 27. 27 to the power 1 over 3 gives me 3. (64 to the power of 1 over 3 is going to be 4, and 125 to the power of 1 over 3 is going to be 5. Alex asked a really good question. What if it's the power of 2 over 3? And we're actually going to look at that, and I'm going to come up with a fancy little rhyme for you guys to help you remember it. So hopefully you'll remember it a little bit better. It's kind of like the foil thing. It's kind of like the feeding the chickens. This time we have another little rhyme to remember it. So we're not going to double it, but you're close, Taylor. We'll look at it here in a second. So anything to the power of a half is the same thing as taking the square root. Anything to the power of a third is the same as taking the cube root. Anything to the power of 1 over 4 would be like taking the fourth root. So if I had something squared, like 2 squared would be 2 times 2. If I have 2 to the power of 1/2, I'm going to say, okay, I don't want to square that thing, but I want to figure out what number multiplied by itself gives me that thing. Same thing with let's go 2 to the power of 1, maybe 2 to the power of 2, or let's go 2 to the power of 3. It's 2 times 2 times 2. Gives me 8. If I have 2 to the power of 1 over 3, it's what number multiplied by itself 3 times gives me that number. So we're squaring it or taking the square root. We're cubing it or taking the cube root. We're fourth powering it or taking the fourth root of it. So let's continue on here. And Taylor, yes, it'll be a decimal, but most of the questions in this unit will work out really well, so we won't run into decimals. Sometimes the exponent can be a decimal and we'll have to convert it to a fraction, but that, generally speaking, doesn't happen too much. So in grade 9, you learn that we add our exponents if we're multiplying and the bases are the same. So I have a base of a to the m over n. We've used that a bunch of times. So we can extend this law to fractional exponents with a numerator of 1. So the example here, I have 5 to the power of 1/2 times 5 to the power of 1/2. If I go 5 to the half plus a half, 2 halves give me 1, and 5 to the power of 1 is just 5. If we had the square root of 5 times the square root of 5, we get the square root of 25, and we know 25 is a perfect square, which is just going to give us 5. So 5 to the power of 1/2 and 5 under a square root sign are the same. I guess I could put expression. They're the same thing. So we write this as a law. Anytime I have a fractional exponent like 1 over n, whatever's on the bottom is going to be the same as whatever's in front of my root sign. So raising a number to the exponent of 1/2 is equivalent to taking the square root of the number. So anytime you see an exponent of a half, it's a square root. If you see an exponent of a third, it's the cube root. They mean the same thing. So we're going to look at a few examples here, and They do get a little bit more tricky as we move on. So we're going to start with just a numerator of 1 to begin with, and then we'll move on to a numerator, something different, like Alex had a question about 2 over 3. So we'll see what that looks like. So in the orangey, yellowy box here, this is kind of the textbook definition we're dealing with. If we have something to the power of m over n, whatever's on the bottom goes in front of the radical, and whatever's on the top goes behind it. Don't worry about this if you're looking at it and you're like, oh, that's just a lot of letters. I thought we were doing math. This is confusing. We'll do it kind of a step at a time and we'll get there. So let's look at our first example as kind of our practice here. I have 27 to the power of 1 over 3. Now I know I can just plug it into my calculator, but this says evaluate without using a calculator. So we're going to say, okay, I know I can switch back and forth between a fractional exponent and a radical. So what I'm going to do is I'm just going to write a radical. I'm going to put my 27 under it. And then I have this 1 over 3. And whatever's on the bottom is going to be what's in front of my radical. So we haven't been exposed to a lot of fractional exponents yet, but we have dealt with lots of cube roots so far. The whole last unit we did was cube roots and square roots. So I know the cube root of 27, that's a perfect cube, and that's just equal to 3. So 27 to the 1 over 3 might not make sense, but the cube root of 27 does. All right, this one kind of ratchets the difficulty up a little bit more. I have 0.25 to the power of 1/2. Now, I can write this a couple different ways. I can write it as 0.25, and instead of writing it as a fraction, I can put a 2 out front, but when I take the square root, I generally don't put the 2 there because I just know it's a 2. So I'm going to get rid of that. And you're thinking, well, I don't know what the square root of 0.25 is. You do though, because 0.25, if I took out this 0 point and I just asked you, what's the square root of 25? You would just tell me, that's easy, Mr. Borden, that's 5. All right, let's put the 0 point in there again. Now what's the square root of 0.25? Alex is on it. Gives me 0.5. Or you can think of it this way. I'll do it, I'll convert this 0.25. I know that's 1 over 4. And instead of writing it as a fractional exponent, I'll just write it as a radical. Number multiplied by itself gives me 4. Well, you know what that is. 1 over 2, which is the same thing as 0.5. So you guys know how to do this stuff. You're smarter than you think, but a lot of times when it's something new, you're like, oh no, I'd never done the square root of a decimal before. Well, just pretend the decimal's not there, and it's the exact same process. 0.25, get rid of the point, it's just 25. That's just 5. So put the point back in, and you're good to go. Let's continue on here. Negative 8 to the power of 1 over 3. I can rewrite this as negative 8, and because my denominator is a 3, I'm going to put a 3 out front. Now, you may not know what negative 8 to the power of 1 over 3 is, but if I asked you to figure out the cube root of 8, you'd say, oh, that's easy, Mr. Borden, that's a perfect cube. 2 times 2 times 2 is 8. This one's negative, so it's just negative 2. Easy peasy. All right, a little bit more difficult again. Instead of a fractional exponent, I'm going to write it as a radical. I have 16 over 81, and I had 1 over 4, so whatever's on the bottom goes out in front. That's a good question, Abby. Could you also write it as negative 1 cubed root 8? Yeah. So I could write it as negative 1 times cube root of 8, which equals -1 times 2, which equals -2. If you like to do it that way, that's completely acceptable. There's nothing wrong with that. All right, fourth roots. I don't have these memorized, but I'm thinking 16 is a pretty small number, so it has to be 2. And the bottom, 81, likely going to be 3. So I could just do the math in my head. What's 2 times 2 times 2 times 2? 16. And 3 times 3 is 9, times 3 is 27, times 3 is 81. So 2 over 3. There you go. So in all these examples, I had a fractional exponent. The top of my exponent, or the numerator, was just 1. So that was kind of a basic, basic as these get. Let's look at a little bit more complex kinds of examples. The ones with the numerator not being 1. This is what Alex asked about way back at the beginning of the lesson. Jumping the gun. All right, so we have here exponents that aren't 1. They are fractional. The top is 2, the bottom is 5. Right radical form in 2 different ways. So it's not actually even asking me to calculate it. It's just asking me to write it 2 different ways. So I know that as a general rule, a to the power of m over n, this is kind of the rule that we wrote at the beginning, or that was in that yellow box. It's going to be a to the power of m with the n root out front. So if I rewrote this, 26 to the power of 2 over 5, I'm just going to replace everything with numbers. So in this case, a is 26. So my 26 goes under the root sign. All right. The n was on the bottom and it ended up in front. What's on the bottom here? Well, I have a 5. So I can put the 5 in front. And then the 2 was on top. It ended up out back. So I'm going to put the 2 out back. So I can write it that way if I want. There's another way I could write it. Same process. I have 25. Sorry, this is 26, not 25. I'm going to write it as the 5th root. And instead of having the squared outside, I can bring it inside the bracket if I want. It doesn't matter where you put it. You can put it outside and leave brackets around this whole thing, or you can bring it inside your root. They both mean the same thing. You just need to figure out which one you like better. And in some cases, it's going to work out for you to have it outside, and in some cases, it's going to work out for you to have it inside. Here's where my fancy little rhyme comes in. I didn't think of this. I don't remember who said it to me, but I liked it. So when I have something like 26 to the power of 2 over 5, the rhyme is flower's the power, root is the root. I know flower and root, rhyming root with itself isn't the best, but the idea is this. Anytime I have something on the top, it's kind of like a flower. Here's my little flower. A little leaf. And then I have some ground. And then under the ground, I have a bunch of roots growing down into the ground. So when I say flower's the power, what I mean is whatever's on top is the power, and whatever's on the bottom is the root. Think of the division symbol as being like the ground. So we'll write flour is the power, and the root is the root. That's my rhyme. Why did we carry the top exponent on the last question? Why did we carry it? I'm not sure what you mean by carrying our top exponent. We moved it as the exponent. Maybe you can clarify while I do this next two here. Basically, we're just rewriting this. So 6 to the power of 5 under the square root sign. If we do flour is the power, root is the root. What is in front here? Well, it's just a 2, but I don't write it ever. So I know my root is 2, and my flour is 5. Flour is the power. What is the power? 5th power. So if I want to write this as a fraction, I have 6 to the power of 5 over 2. All right, like on 2, you put the 2 at the back of the 26, but didn't do it on the last page. On the last page, Taylor, we had, the top was all ones, which is different than what we're dealing with now. Now our numerators are numbers that aren't 1. They're 2s and 3s and things like that. So the reason I didn't put the 2 down before is because there was only a 1 there. So I could have, Taylor, if you wanted to think of it this way, I could have put this all to an exponent of 1, because that's what my top was. It was a 1. But anything to the power of 1 is just itself. So it's just one of these steps in math that we don't necessarily need to do, because it's just additional writing, and mathematicians are always looking for ways to do less work, because they're very lazy. All right, so the second one here is a radical, and we need to convert it into a fraction. So again, I will go to my lovely little rhyme. I'll probably say it 1,000 times before this unit's done. Flour is the power, root is the root. I have a root of 4, I have a 3 for a power. So I write down my 19. My power is my flour, and my root is a 4, so it's going to go on the bottom. We don't really even need to evaluate these things. As long as we can understand how to convert back and forth between them, we're doing okay. So the second part here down below is actually evaluating them. So converting back and forth and just simplifying if at all possible. So evaluate with rational exponents and rational bases. Remember, rational numbers are essentially it can be written as a fraction. So I have 0.01 to the power of 3 over 2. You need to resist the urge to just plug this into your calculator. These questions will, generally speaking, all just work out really nicely. So let's convert this into a question with a radical. Flour is the power, root's the root. I see the bottom is 2, so I know I'm dealing with the square root of something. I don't have to write the 2 out front, because it's generally not written that way. And my power was 3, so I'm going to have my 3. I'm going to leave it outside. You could bring it inside. I'm just going to do it after. So I'm going to do everything inside my brackets. What is the square root of 0.01? What number multiplied by itself gives me 0.01? If you know what that is, excellent. If you don't, that's okay. You can always plug it into your calculator. Take the square root of 0.01. You know it's going to be 1, because when we deal with ones, we can't really end up with any other numbers, but it's just 0.1. I still have this cubed out back, Now if I multiply 0.1 by itself 3 times, basically all this question is doing is just moving a decimal place around. So if I go 0.1 times itself, I get 0.01. And if I go 0.1 one more time, I get 0.001. Maybe not the best example to start with because it's kind of hard to see what's going on. You're just moving the 0 and things around. What I would like you to do or suggest you do is test out your calculator. So the question we were dealing with was 0.1 to the power of, bring it back, 0.01 to the power of 3 over 2. So I'm going to plug it in here. 0.01 x to the y, 3 over 2. Just to confirm that what I've done in my calculator is going to work out. So this is where it's really important that you understand how to use your calculator and you can trust in the answer that it's giving you, because it's a good idea to check your answers to these questions once you get to the end. So if I plug that in, I throw in the enter there, and I see that I get a really strange number, 1e negative 18, which is not what I was hoping for. Let's try that again. 0.01. There we go. Let's obviously entered something wrong. So I have 0.01 to the power of 3 over 2. And I get 0.001, which is exactly what I ended up with on my page. So again, calculator is half the battle sometimes. 0.01 to the power, maybe if I get rid of that, I can go to the power of 3a over b to the 2. See if that works out for us. 0.01. It just depends on how your calculator is willing to accept these numbers. So it's kind of up to you to make sure you understand your calculator. If you're having issues with it, there you go. You gotta speak up and ask for help, or see me, or send me the model number of your calculator and I can find it and figure it out for you. But until you do that, you're probably going to be a little bit confused. You're getting 0.03. What's probably happening is your calculator is not liking the order you're putting things in. So when you plug it in, you probably have to put the 3 over 2 in brackets. Even though if you don't have the secondary display screen up above like I have here, if you don't have that, that's fine. You'll still likely have a brackets button on your calculator. So you're going to want to use that even if it's not showing up in the top. So pick something really easy that you know how to do, just like 4 to the power of 1/2. It's just the square root of 4, which is 2. So when you're plugging it in, again, 4x to the y, bracket 1 divided by 2, close the bracket. Calculators don't like it if you don't close the bracket either. So if that's something that's kind of happening to you, then make sure you're closing that bracket. Just keep trying it different ways until it works out. And then whatever you just did, do it that way all the time. I'm going to continue on here with this. In the end, you likely won't need to use your calculator very often, but sometimes it's kind of handy to just check your work. All right, so negative 27 to the power of 4 over 3, I'd think about it. I don't know what that is. 4 over 3 just doesn't make sense, but I can rewrite this as a radical, and hopefully that will clarify things a little bit. So flour is the power, 4 is my flour, it's going to be my power. And the root is 3, and I'm going to write it out front because it's a 3, not a 2. Put in the negative 27 under my radical sign. Now at this point, I know what the cube root of 27 is. That is 3. And because it's negative, I'm going to write this as negative 3. I still have this power of 4 on the outside. So I'm going to go, okay, power 4, 3 times 3 is 9 times 3 is 27 times 3 again is 81. And there we go. End up with 81. You could check it in your calculator if you want it, or you can just trust me. It's up to you.